In the last video, I had started the topic family of spheres, and in that video I had shown that S plus lambda u equal to 0 is a family of spheres. But then one has to be sometimes careful. S plus lambda u equal to 0 may not always be a sphere, and therefore you have to restrict the value of lambda. So this example is going to illustrate this fact. So I wish to keep the videos small from the point of view of ease in uploading it, and therefore I had stopped the video at the point of the illustration. So the intended example is this. I look at this sphere, S equal to 0. So S equal to 0 will be a sphere. I look at the plane u equal to 0, and S plus lambda u equal to 0 will be this equation. So for suitable values of lambda, this equation will represent a sphere, and the sphere will have this as the center, 1 plus lambda upon 2, comma minus lambda by 2, comma minus lambda by 2. Okay, and the likely radius squared is going to be this quantity. So r square, r is the radius of the sphere, is u square plus v square plus w square minus of d. All right. So that's minus of u and its squared is here. That's minus of v and its squared is here. This is minus of w and its squared is here. This is a d, and minus of d is 2 lambda. So after the simplification, so just open the brackets, square them out. So what you get is 1, and then 2 times 1 into lambda by 2, which is this, and then you get lambda square by 4. You again get a lambda square by 4 from here and here. So 3 times of lambda square by 4, and this gives you 2 lambda. So 3/4 of lambda square, 2 lambda plus lambda is 3 lambda and 1. Okay. But we know that this quantity is not always non-negative. So if you think of this as f of lambda, then the graph of f of lambda will be a parabola opening upwards, because the coefficient of lambda square is positive. Okay, so we will have a parabola. I wish to find these points, and therefore I look at the equation 3/4 lambda square plus 3 lambda plus 1 equal to 0, which will be same as lambda square. So I'm multiplying this by 4 by 3. Okay, so when I multiplied, I multiplied by 4, so lambda's 4 by 3, yes, so 4 by 3, so I wish to look at this. So what are the roots of this quadratic? Lambda will be equal to -4 plus minus under root b square minus 4ac divided by 2. So this is same as -2 plus minus so this is 16 2 by 3, 16 into 2 by 3. Okay, so let me take a 4 out. So 4 minus 4 by 3. 4 minus 4 by 3 is 4 into 1 minus 1 by 3. So that's 4 into 2 by 3. Okay. Just check that. Okay. So, alright, so both the points are negative, right? Okay, so the parabola will look like it's going to look like this. This point is minus 2 minus 2 root 2 by 3, and this point is minus 2 plus 2 root 2 by 3. Okay, so for all the values of lambda between these 2 points, okay, f lambda takes a negative value. So if this is your lambda, then f lambda is negative. Okay, so s minus lambda u equal to 0 is not a sphere. If lambda belongs to the open interval minus 2 minus 2 root 2 by 3 minus 2 plus 2 root by. All right. Okay, so one needs to be careful when you make a statement like this, that s plus lambda u equal to 0 is a sphere. So that's all in this video. In the next video, I will continue with the topic family of spheres. But then we will be looking at the intersection of 2 spheres. I will first show that the intersection of 2 spheres is a circle, and then we will write down the family of spheres to that circle.